This is a status update of phase 1 of the mini hexapod that I am sort of calling Nico for now. So here's the old hexapod design, Dimitri as I call it, and it's really rather quite large for what it is, especially for the Edison chip. You can see the size of the Edison chip here, right with the camera. So this little Edison chip can power everything, but this platform is really much too large, and it really dwarfs the Edison. So enter Nico, something much more size appropriate for the Edison board. Now I'm going to talk a little bit about the construction of Nico. This follows the same original designs as Dimitri. I couldn't just directly scale it down. I had to redesign everything. That's because the motors don't quite fit. The motors weren't a perfect scaled down version of the MX28s. But it wasn't too hard to design and build. It uses these new rivets so things can be assembled almost entirely without any tools. So you just pop in these rivets by hand and then everything is fairly snug in place. The motors are the XL320 made by Robotis, so it uses a very similar protocol. It's a newer version of the protocol which required some software to get working. The head mechanism here still has a little bit of work to be done. Instead of using 3 motors, it now uses 2. This is just to save space. There currently isn't any linkage right here. It's something that's currently being worked on. But the camera right here is an iQB, which is available from Amazon. I did have to do some custom modifications to it to get rid of the standard USB connector that sticks out the back. And so I directly soldered this wire, this USB cable, to the pins inside just so that I could sync back the camera in this direction as much as I could. So it is a very small profile. You can see there's the Edison breakout board on there, and the Arduino style board would be much too large for this design. Also, this uses the battery. Here's the battery. It's a 2200 mAh. It's a 2-cell LiPo, so it operates at 7.4 volts when it's fully charged, and that slides in the back like so. Now originally this battery had some pretty thick cabling that I decided to cut off here because I'm not going to be consuming anywhere near the current, which is good because the battery should hopefully last a long time. And instead I'm just going to use this charging port here to power everything up. Now I was going to use this USB to AX, which is this little board right here, to communicate to the motors instead of the FTDI chip. However, I broke this somehow, I'm not quite sure, so I think that's somewhere on the way. But this little board is going to be underneath the Edison breakout board, so the Edison breakout board is going to have to be raised up just a little bit. So for now, just to get to work, I have to use this USB to Dynamixel. And the reason I'm not using this now is because, again, this is much too large for the profile of little Nico here. I just got Nico walking about an hour ago, and I did some light tuning to make sure that it walked pretty good. And this is the same program that I used in Rome and New York Maker Fairs. This program is not perfectly well suited for Nico right now. There is some tuning that will need to be done, but at least I can show it walking around and doing some other motions. So I'm powering it up right now. Okay. And this program is controlled by an iOS device. In this case, I'm going to be using my iPad. Okay. So now I'll try to make him just walk around a little bit. Just going to use the joysticks here. Right now that USB to Dynamixel is just sort of hanging out the back. And some of the other excess loose wires will be better hidden when I get a couple of shipments in of connectors. There's still some work to be done on the simulation here. You can see with the leg angles, everything kind of gets screwed up. So this is just having to update. I've updated the code so that my latest version is running on both Edison and my computer with my simulations. So that's why it looks so funky. So I can go ahead and try and show some of the other motions of this program. Again, these are not tuned very well, so they don't work out that great. But this is the body rotation. Okay. This is the head bobbing. Okay. And then the last one is the fist pumping. There we go. And then I can take it back to walking. So there will be a little bit of tuning to do, especially if we want to make it walk fast, which I think would be very desirable. But other than the USB to Dynamixel hanging off the back, when I get that replaced with the USB to AX, it'll all be very well self-contained.